Hi, students, and welcome to today's lesson. I'm Mr. Simpson. Today, we will explore the question, how are different forms of energy used in the Dort rail system? Are you ready? Grab your pencil and your science journal, and let's get started. Do you remember our chart? We used this chart to record observations about energy that we identified in the video clip of the Dort rail train. After our investigation with circuits in the last lesson, what other questions do you have about circuits and forms of energy used in the Dort rail system? Do you wonder, can the wires in a circuit be arranged differently but still work to power devices on a Dort rail train? Or maybe you want to know, how can Dort rail trains use multiple forms of energy at the same time? Today, we will compare different circuits to investigate the question, how can different devices and forms of energy be used at the same time in the Dort rail system? In the previous lesson, we created circuits that transformed electrical energy into another form of energy, like sound, mechanical, or light. In today's lesson, we will transform electrical energy into sound, mechanical, and light energy by using three devices in a single circuit. Here are our materials for today: two batteries and battery holders, a light bulb, a buzzer, and a motor. We also have four wires with alligator clips. How can we arrange these materials to create a circuit? Remember, we want this circuit to transform electrical energy into three other forms of energy. I have an idea. We can connect an alligator clip to the battery. Then connect the other end of the alligator clip to a wire from the buzzer. What should we do next? Let's add another device, the light bulb. We can use another alligator clip to connect the light bulb to the buzzer. Great. Now what? Oh, we have another device. The motor. Let's use another alligator clip to connect the light bulb to the motor. Now we can use our last alligator clip to connect the motor to the battery. Let's see what happens if we add another battery. What did you observe? I observed only one type of energy, sound energy. I did not observe light energy or mechanical energy. Do you think the sound was louder when I added the second battery? I do. Let's look at this diagram together. It represents how we connected the devices in our circuit. Where should we look first? The key. Let's use the key to identify the parts of the diagram. What does this symbol represent? Did you say the battery? You're right. And what does this symbol represent? This represents a device, right? And what does this last symbol represent? If you said the wire, you're right. We connected all the devices in a closed circuit, but only the buzzer is working. Think back to the video clips we watched in our last few lessons. Which devices did you observe in the video clips of Dort rail trains? Did you observe overhead lights? I did too. What else did you observe? Did you say that the doors opened and closed? Yes, they did. We also saw speakers that played announcements and music. Compare our observations of devices in a circuit with your observation of devices in a Dort rail train. What do you notice? The devices in our circuit didn't work at the same time, but on the Dort rail train, the motor works at the same time as the lights, the doors, and the speakers, right? In our circuit, only the sound worked. Our circuit isn't like the train at all. The different devices did not all work in this arrangement because each device needs a different amount of electrical current from the batteries. This time, we will create and test a circuit that looks like this one. How should we arrange our materials in order to build the circuit represented in the diagram. Did you say we should start with the battery? I agree. We'll place the battery on the table and attach wires to either side. How many wires? I see one, two, three wires on the top side of the battery. Are there three wires on the bottom side of the battery too? Yes. I think we should use alligator clips to connect a device to wires from each side of the battery, like this. That way we complete the circuit. And then we should connect the other two devices to the wires in the same way. Do you think all three devices will work with this setup? Let's find out. Wow, all of the devices are working this time. How does this circuit compare with your observations of the dark rail train? Did you say that all three devices turn on, just like on the train? I agree. This circuit is like the train because it has lights, movement, and sound at the same time. Let's see what happens if we disconnect the motor. Hey, when we disconnect the motor, the other devices still work. That must be because each device has its own closed loop back to the battery. Why might engineers use this type of circuit in a dark rail train? Well, if one device goes out, the other devices will stay on because they're each connected to an energy source. Let's use what we have learned to create a class model. What can we add to our model? Well, we've learned about the flow of energy in previous lessons. Energy comes from the substation and flows through the overhead wires. Then the energy flows down the pantograph into the train and through the wheels and rails back to the substation in a closed circuit. Let's use arrows to show the flow of electricity, and we've learned that energy also flows to other parts of the train. Let's add arrows to show the flow of energy to the lights and the doors of the train. We can also add labels. Lights turn on and doors open. Great. And hey, we also learned about the pantograph. We know that the pantograph has conductors and insulators. Now let's add an explanation for our model. We can say that electrical energy travels through the overhead wires, through the pantograph, and into the train. The pantograph uses conductors and insulators to direct the flow of electricity. The electricity flows through the wheels and rails and back to the substation in a closed circuit. Devices on light rail trains transform electrical energy into light, sound, thermal, and mechanical energy. Fascinating. So, how are different forms of energy used in the dark rail system? Now we know that electricity flows through closed circuits in the train to power different types of devices. Through our investigation, we learned that circuits can be arranged to power different devices at the same time. Now let's use what we've learned to update our class chart. What should we add to our chart? We can write circuits can be arranged in different ways so that multiple devices can work at the same time. Good work creating another class model and updating our class chart to show everything that we've learned so far. Your first task after this lesson will be to draw the class energy model and provide an explanation. Your second task will be to update the class chart. In our next lesson, we will continue to explore the dark rail train. I can't wait to learn more. Let's review your tasks for today. First, draw the class energy model and provide an explanation. Second, update the class chart.